Hello 7th graders. Today we're going to start our journey into our chemistry unit. This unit is a little bit more intense than what we were starting out with at the beginning of the year. To start us off, we're going to do some reading today. We're going to look at some of the vocabulary words and break them apart with you. Today, while we're reading, we are going to be practicing a reading strategy called summarizing. I'm sure most of you are already familiar with it. You practice it in ELA. After reading a small section, I have them all highlighted, you will be asked to write down the most important part of that section. We will work through several examples together. You'll be asked to do this on your own next time. So, for the very first one, for section 1, I kind of have them all highlighted in similar colors here. So I'm going to read this with you, and then we're going to answer the section. So our reading for today is called Development of the Atomic Theory. So we're going to be talking about atoms and electrons and some molecules today. So section number 1, how does new information change? Scientific ideas. Have you ever watched a mystery movie and thought you knew who the criminal was? You may have changed your mind once you saw a new fact or clue. This is what happens in science. Sometimes an idea or a model is changed when new information is collected. One example of this is the atomic model. Our ideas about atoms have changed over time as we gather new information. For this first section, I want you to pause for a second and think, what was the most important part of those couple of sentences? If you had to tell me one thing, just one sentence about it, what would you tell me? Alright, if I were you, this is what I would write. So for example, the most important part, or summarizing it in just one sentence, I would say, science ideas and models can change over time. Feel free to pause the video and rewind and re-listen to everything as we go through this, but I'm going to keep moving. So, section number 2. What is an atom? Imagine cutting something in half, then cutting again and again. Could you keep cutting forever? Around 440 BCE, a Greek philosopher named Democritus studied this question. He thought that you would eventually reach a piece of matter that could not be cut. He called this particle an atom. It was a long time before there was scientific evidence that Democritus, pretty sure that's how it's said, was right on track. We now know that all matter is made up of tiny particles called atoms. An atom is the smallest particle into which an element can be divided and still keep its properties. The figure shows images of aluminum atoms taken with a scanning, tunneling electron microscope. Early scientists had ideas about atoms and models of atoms, even though they did not have pictures of them. Let's take a look at this picture before we write our sentence. So aluminum cans are made out of atoms, and we can see those here. Notice the regular repeating pattern of the aluminum atoms. Alright, from section 1, what was the most important piece? What can we take away from these 3 paragraphs? Alright, if I were you and I were writing this, this is what I would have. And this is just an example. You can change it however you want. So Democritus gave the name atom to describe the smallest whole particles. Alright, section 3. Let's scoot over here. What was the first scientific theory of atoms? The first scientific theory about atoms was published by John Dalton in 1803. Unlike Democritus, Dalton based his ideas on experiments. His theory helped explain observations that he and other scientists had made about elements and compounds. Dalton's theory stated that all substances are made out of atoms. Atoms are small particles that cannot be created, destroyed, or divided. All atoms of one element are exactly alike, and atoms of different elements are different. Atoms can join with other atoms to make new substances. Many scientists agreed that Dalton's theory explained much of what they saw. However, scientists later found new information that did not fit Dalton's theory. The atomic theory was changed to more correctly describe the atom. Alright, again pausing for a moment, looking at this section. What was the most important thing? If you had to tell me just one thing, what would it be? Alright, if I were you, this is something that I would write. Everything is made up of atoms was part of Dalton's scientific theory of atoms. You could also say anything about Dalton created a theory about atoms that stated 3 different facts. You could even go on to state them for me in an abbreviated form. But trying to make this as short as sweet as possible, I picked what I thought was one of the most important ones, that everything is made up of atoms. Moving to section 4. How were electrons discovered? In 1897, J.J. Thompson, a British scientist, discovered that atoms are not the smallest particles. They are even smaller particles inside the atom. Thomson made this discovery when he was experimenting with invisible beams called cathode rays. Cathode rays were made by connecting a special glass tube to a source of electricity. To find out more about cathode rays, Thomson placed 2 metal plates inside the tube. One plate had a positive electrical charge, and the other had a negative charge. Thomson discovered that the cathode rays are attracted to the plate with the positive charge. Here's a picture of his experiment. If we were to make one sentence for a quick summary of this section, what would you say? I'm going to leave this one up to you. So if you need to, rewind the video and go back to help you write your sentence for section 4. Alright, section 5. Thomson's Plum Pudding Model. Thomson concluded that cathode rays must be made of tiny particles that come from atoms. Since the particles are attracted to a positively charged metal plate, the particles must have a negative charge. Remember that opposite charges attract each other. These negatively charged particles are called electrons. Thomson's experiment showed that atoms contained electrons, but it did not show where the electrons are located within an atom. Thomson suggested that electrons might be scattered throughout the atom. This new model of the atom was called the Plum Pudding Model. It was named after a popular dessert at the time. Today, we would probably call this a chocolate chip ice cream model of the atom. Alright, for section 5, what would you write? If I were you, this is something that I would write down. Electrons are negatively charged and were attracted to a positively charged plate. So I have something about electrons being negatively charged, and then the fact that they're attracted to a positive charge. You could have said anything about Thomson's plum pudding model, discovering electrons, All of these things are important, but it's how you summarize the section. That's what's important. How did Rutherford study the atom? This is section 6. In 1909, one of Thompson's students wanted to test the theory that electrons are scattered throughout the atom. Ernest Rutherford decided to shoot a beam of tiny positively charged particles at a thin sheet of gold foil. Rutherford guessed that atoms are soft blobs of matter, with electrons and positively charged particles scattered throughout. He thought that most of the particles would pass right through the gold atoms. Particles that hit other particles would stop or bounce to the side. When Rutherford performed the experiment, he found that most of the positively charged particles did pass through the gold foil. Some were deflected sideways, just as he expected. What surprised him was that some particles bounced straight back. Here's a picture of Rutherford's gold foil experiment. What would you write for section 6? I'm going to leave this one up to you. Section 7. What was Rutherford's atomic model? The Plum pudding model did not explain what Rutherford saw. He reasoned that there was only one way that the positively charged particles could bounce straight back. That was if they hit a very dense part of the atom that had a positive charge. Remember that identical charges repel. He concluded that most of the matter in the atom must be in a very small part of the atom. Based on the results of his experiment, Rutherford proposed a new model of the atom called the nuclear model. In this model, the center of the atom is a dense, positively charged area called the nucleus. The electrons move outside the nucleus in mostly empty space. Here's a picture of what they're talking about. What would you write for section 7? Here's an example of what you could write. The nucleus of an atom is a very dense area with a strong positive charge. Section 8. What did Bohr discover about the atom? In 1913, Niels Bohr, a Danish scientist, studied the way that atoms react to light. He made a slight change to Rutherford's model based on his observations. Bohr proposed that electrons move around the nucleus in definite paths or orbits, called energy levels. In Bohr's model, electrons could not exist between these levels. Think of the levels as rungs on a ladder. You can stand on the rungs of the ladder, but not between the rungs. However, the electrons could jump from one level to another as they gained or lost energy. Once again, the atomic theory was changed to account for new data. What could you write for section 8? I'm going to leave this one up to you. Section 9, the last one. Oh, and here's a picture of the Bohrs Model. What is the modern atomic theory? Atomic theory has changed over the past 100 years. Scientists such as Erwin Schrödinger from Austria and Werner Heisenberg from Germany have done important work. They have made observations that show that the Bohr model is not quite right. Scientists still think that electrons are moving constantly around the nucleus. However, they now know that electrons do not orbit the nucleus like planets orbit the sun. In fact, no one can predict the exact path of an electron will follow as it moves around the nucleus. However, scientists can predict where electrons are likely to be found. In the modern atomic model, the locations of electrons are described within electron clouds. Electron clouds are regions where electrons are most likely to be found. The figure below shows this model. What would you write for section 9? Here's my example. Electrons can be unpredictable. We are still discovering more about the atomic theory.